Special Science Bulletin, the journey to search for life beyond Earth, the secrets of Europa, and the big questions about the universe, latest updates from November 2025. Imagine yourself sitting in a completely dark room, with only the flickering light coming from your computer screen illuminating the space, the soft whirring sound of the computer fan filling the air, and right in front of you, an image of a gigantic sphere of ice floating silently in the vast blackness of space, surrounded by brilliant streaks of light emanating from the enormous gas giant known as Jupiter. That incredible world is Europa, the icy moon of Jupiter, a place where millions of people here on Earth are pinning their greatest hopes. Could life truly exist somewhere beyond our own blue planet? The age-old question of whether we are alone in the universe is no longer just a distant dream or a fanciful idea from science fiction stories. It has transformed into a real and tangible mission, driven forward by advanced spacecraft, the brightest minds humanity has ever produced, and an intense, burning desire to discover the truth. Is it possible for life to emerge not just once, but twice within the very same solar system that we call home? Today, let us embark together on an extraordinary journey of exploration into Europa, this frozen world that hides a massive subsurface ocean beneath its icy crust, a location where scientists strongly believe the very first forms of microbial life outside of Earth might be hiding right now. We will delve deeply into the Europa Clipper mission, the remarkable spacecraft that is currently traveling toward Jupiter, equipped with some of the most advanced technologies ever created by human hands. Along the way, we will uncover profound physical mysteries that connect everyday phenomena to the extremes of the cosmos, from the boiling point of water at the summit of Mount Everest to the bizarre pressures on the surface of the Sun, and even from the intricacies of string theory to the mind-bending possibility of tearing the fabric of space itself. Europa, the icy jewel of Jupiter, a world where life might be hiding in plain sight. Europa is far from an ordinary moon. It was first discovered in the year 1610 by the legendary astronomer Galileo Galilei, during his groundbreaking observations with one of the earliest telescopes. Europa is one of the 4 largest moons orbiting Jupiter, collectively known as the Galilean moons, named in honor of their discoverer. However, what truly sets Europa apart and makes it the focal point of intense scientific interest is not merely its size, although it is only about 10% smaller than Earth's own moon, but rather the existence of an enormous ocean of liquid water buried deep beneath a thick shell of ice that ranges from 10 to 30 kilometers in depth. Picture this vividly. You are gliding across the surface of Europa on ice skates, hearing the sharp scraping sounds as your blades cut into the pale grayish-white ice, with massive cracks stretching for hundreds of kilometers in every direction, resembling frozen rivers etched into the landscape. All around you is the chilling darkness of outer space, illuminated only by the faint, distant glow of the sun and the dazzling reflected light from the colossal planet Jupiter looming overhead like a watchful giant. Directly beneath your feet, just a few dozen kilometers below that icy crust, lies a salty ocean that plunges to depths of up to 100 kilometers, containing a volume of water that is more than twice the total amount found in all of Earth's oceans combined. This hidden sea is not a frozen wasteland. Scientists have gathered compelling evidence over decades from missions like Galileo and Hubble that it remains liquid and dynamic to this day. Experts are convinced that this subsurface ocean is very much alive in a geological sense. It is warm enough in places, constantly in motion due to powerful tidal forces, and potentially teeming with the chemical ingredients necessary for life. The primary reason for this warmth is a fascinating phenomenon called tidal heating, caused by the immense gravitational pull of Jupiter itself. Think of Europa as a giant rubber ball being relentlessly squeezed and stretched. Jupiter, with a mass that is 318 times greater than Earth's, tugs powerfully on Europa as it follows its slightly elliptical orbit. With every revolution around the gas giant, Europa is compressed, elongated, and deformed in a rhythmic cycle. This constant flexing generates tremendous internal friction and heat, more than enough to melt the ice from below and sustain a global liquid ocean for billions of years, even though the surface temperature hovers around -160°C or colder. Deep within this hidden ocean, researchers hypothesize the presence of hydrothermal vents on the seafloor, eerily similar to those discovered in Earth's deep oceans, such as along the mid-Atlantic ridge or in the Pacific's hydrothermal fields. These vents spew superheated water rich in minerals, salts, and essential organic compounds like carbon, nitrogen, sulfur, and phosphorus, all of which are the fundamental building blocks required to assemble the complex molecules of life. Observations from NASA's Juno spacecraft, which has been orbiting Jupiter since 2016, have revealed plumes erupting from cracks on Europa's surface, ejecting salts, minerals, and even organic materials into space, forming delicate clouds that shimmer faintly in the distant sunlight. These plumes provide direct evidence that the ocean below is interacting with the surface, offering tantalizing clues about its chemistry and potential habitability. The Europa Clipper mission, humanity's ship of hope, journey updates from November 2025. In late October of the year 2024, at the Kennedy Space Center in Florida, under a night sky brilliantly lit by the floodlights of the launch pad, SpaceX's powerful Falcon Heavy rocket roared to life with an earth-shaking thunder. Flames and thick white smoke billowed outward as the rocket lifted the Europa Clipper spacecraft skyward, marking the beginning of one of the most ambitious interplanetary voyages in history. Thousands of engineers, scientists, and enthusiastic spectators gathered there, erupted in tears of joy and cheers as the vehicle soared into the heavens. The Europa Clipper is no small probe. It stretches to a length comparable to a full-sized basketball court when its arrays are deployed. It is outfitted with enormous solar panels that span wider than a Boeing 747 airplane's wings, cutting-edge ion propulsion engines for efficient long-distance travel, and a suite of 9 highly sophisticated scientific instruments representing the pinnacle of human engineering ingenuity. As of the latest updates in November 2025, the Europa Clipper has successfully completed a crucial gravity assist maneuver near Earth in March of 2025, using our planet's pull to slingshot itself toward the outer solar system. Currently, the spacecraft is cruising steadily toward Jupiter at optimal speeds, with all systems reporting perfect functionality from the Deep Space Network communications to power generation. Mission planners confirm that it remains on track to arrive in Jupiter's orbit in April of the year 2030, where it will conduct 45 close flybys of Europa over a 3-year period, dipping as low as 25 kilometers above the surface to gather unprecedented data. Envision the spacecraft gliding silently through the void of space, its massive silver solar wings gleaming like ethereal sails catching the weak sunlight, high-resolution cameras capturing slow-motion details of every fracture and chaos terrain on the ice, penetrating radar beams probing tens of kilometers into the crust, and spectrometers analyzing individual particles and water droplets ejected from the moon's geysers. The 9 super scientific instruments aboard Europa Clipper. The wide-angle and narrow-angle color cameras, boasting 8-megapixel resolution, capture stunning images across near-infrared, visible, and ultraviolet wavelengths. Each photograph tells a detailed story, revealing mysterious reddish cracks possibly stained by organic materials and freshly formed ice regions indicating recent geological activity. The thermal emission imaging system creates comprehensive heat maps of the surface both day and night, hunting for warm spots beneath the ice that could signal ongoing volcanic or tectonic processes. The ultraviolet spectrograph examines Europa's thin atmosphere, detecting plume eruptions and precisely identifying chemical compositions in the exhaled gases. The mapping imaging spectrometer charts the distribution of water ice, salts, organic compounds, and minerals across vast areas of the surface. The magnetometer detects Europa's induced magnetic field, providing irrefutable proof of a conductive saltwater ocean lurking below. The plasma instrument for magnetic sounding studies the interactions between Jupiter's powerful magnetosphere and Europa, shedding light on electrical currents flowing through the hidden sea. The radar for Europa assessment and sounding penetrates the ice with radio waves, echoing back signals to map subsurface layers down to 20 kilometers or more, potentially revealing lakes or even the ocean interface. The mass spectrometer analyzes the chemical environment at the molecular level, capable of sniffing out biosignatures if any biological processes are at play. The surface dust analyzer collects tiny particles ejected from cracks or impacting meteorites, searching for direct samples from the ocean depths. Additionally, the spacecraft is protected by thick aluminum radiation shields to withstand Jupiter's intense radiation belts, smart thermal management systems to regulate temperature swings, multi-layer insulation blankets for heat reflection, and high-gain antennas for transmitting massive volumes of data across 800 million kilometers back to Earth. Life on Europa, microbes or something more extraterrestrial? Realistically, no one expects to find whales swimming in Europa's ocean or intelligent aliens waving hello. The target is far more subtle, extremophile microorganisms thriving around hydrothermal vents, harnessing chemical energy from the environment in a process called chemosynthesis, much like the tubeworms and bacterial mats discovered around Earth's black smokers in the 1970s. If such life is confirmed, two profound scenarios emerge. First, if Europa's life is entirely independent and chemically distinct from Earth's biology, it would prove that life arises easily and frequently throughout the universe, wherever liquid water, energy, and organics coincide. Second, if it shares a common genetic ancestry with terrestrial life, perhaps through DNA or RNA similarities, it might indicate that life originated on one world and was transferred via meteorites billions of years ago, either from Earth to Europa or vice versa during the heavy bombardment period of the early solar system. Either outcome would revolutionize our understanding of biology and dramatically shift humanity's perspective on its place in the cosmos, potentially implying that life is a cosmic imperative rather than a rare accident. From coffee breaks to the sun, strange boiling points and extreme pressures. Amid the excitement at mission control centers, an engineer pauses during a long shift, takes a sip of hot coffee, and casually asks a colleague, "Do you know at what temperature water boils on the top of Mount Everest?" This seemingly simple query unveils surprising physics. At the summit of Mount Everest, which stands 8,848 meters above sea level, the atmospheric pressure is only about one-third of that at sea level, causing water to boil at just 70.5 degrees Celsius. A rough approximation formula is that the boiling point drops by 1 degree Celsius for every 300 meters of elevation gain, making high-altitude cooking challenging and coffee disappointingly weak-tasting due to the lower extraction temperatures. This leads to an even wilder thought experiment: at what temperature would water boil on the surface of the Sun? The Sun's photosphere blazes at around 5,500 degrees Celsius, with gravity 28 times stronger than Earth's. Yet, the pressure there is astonishingly low, merely 0.1 atmospheres, thinner than Earth's upper atmosphere by thousands of times. Calculations show water would boil at approximately 45 to 50 degrees Celsius under those conditions. Of course, no liquid water could ever exist there. Any droplet would instantly sublimate into plasma, its atoms ionized and swept away by the solar wind, scattering across the solar system in a blaze of charged particles. String theory, ripped space-time, and wormholes through the universe. While Europa Clipper journeys onward, physicists back on Earth in laboratories around the world grapple with string theory, the ambitious framework attempting to unify quantum mechanics with Einstein's general relativity into a theory of everything. The Standard Model elegantly describes 3 of the 4 fundamental forces and all known particles, while Einstein's relativity masterfully explains gravity on large scales. Yet, it leaves unanswered why particles have their specific charges, masses, and spins. In string theory, the universe possesses 11 dimensions, most curled up at tiny scales, and fundamental particles are vibrating strings or membranes. Charges could fractionally vary, such as 1/5 or 1/15, depending on how strings wrap around extra dimensions. The ultimate question: can space itself be torn apart? Einstein's equations suggest no, space-time curves and stretches but remains intact. However, quantum effects and string theory allow for possibilities at the Planck scale of 10 to the minus 35 meters, where extreme energies might rip fabric, creating wormholes that shortcut vast distances or connect parallel universes. The cosmic censorship hypothesis proposes that such exotic phenomena are hidden inside black holes, keeping the outside universe orderly and predictable. Conclusion: we are no longer alone in our questions. The Europa Clipper continues its silent voyage through the stars. Physicists refine their equations daily. Humanity holds its collective breath in anticipation. Will we discover life on Europa? Could space truly be ripped open to reveal shortcuts across the cosmos? Might we one day step through a wormhole into another universe entirely? Only time will reveal the answers. But one thing is certain today, we have moved beyond merely wondering if life exists out there. Now, we are actively searching and asking the far more exciting question, where exactly is it hiding? And Europa, that shimmering jewel of ice orbiting the mighty Jupiter, just might hold the key to everything we have ever dreamed of knowing about our place in this immense and wondrous universe.